Swayam Prabha. Digital India. Educated India.
Effective management of greywater is crucial for both environmental sustainability and water conservation. We need technical solutions that can effectively mitigate water contamination, focusing on the removal of contaminants before the discharge of water into rivers and lakes. This is exactly one of the winning teams of ACITE 2024 worked upon. So let's meet the team leader of Tech Chargers and know more about their innovation. Hi, welcome to the studio, Rishikesh. Good to have you here.
Hi. Hi, Vikasji. Good afternoon to you.
So let us know something more about you first before we begin this conversation. You and your team.
To start with, I am pursuing my MTech in Defense Institute of Advanced Technology, which is located at Pune. And my team comprises of total 6 members. I am the team leader. I am Rishikesh Dhotre. Second one member is Ms. Shaista Shabi. She is from biotechnological background. The third member is Mr. Manvender Kumar. He's got electronics background. The fourth member is Mr. Anush Sahu. He's a civil engineer and now pursuing MTech in renewable energy. The fifth member is Mr. Saptarshi Sarkar. He's again a civil engineer. And the last member is Shashwat Dhar. He's a biotechnology graduate and now pursuing MTech in renewable energy.
So before we move further, let us try to understand the gravity of this problem, the greywater issue. It is indeed not a very small one. So can you just tell us more about the issue first, the problem first? How big is it and how critical it is?
It is a grave problem with, it is not only our country, but it is in the entire world as such, but especially in our country, because we are using water endlessly. There is no preservation happening. There are no forests or the rain issues have been resolved, and it will take a lot of time for us to reach the level where we have sufficient water. Especially in urban areas, if we don't treat the water before sending it to the rivers or the lakes, we are damaging the environment much more. So in coming times, there is a possibility that in 5 to 6 years, we may have a severe water scarcity. Even like cities like recently we have seen in Bangalore, Pune, Mumbai, or for that matter, every city, it is a big problem which is happening. Now, this problem is trickling down to the semi-urban areas and the rural areas as well. If we don't treat the water before sending it or we don't recycle it, we are going to have a tough time. So we and myself and our team thought that why not use our technology, whichever we have learned, and use our brains to try and get a viable solution, a sustainable solution to this problem. That's why we participated in this hackathon.
So when you picked up this particular problem, so what was there in your mind? What did you think of? Like you thought that maybe you are in some way better equipped to deal with this? You have some kind of an expertise, or it was somewhere close to your heart? What was the reason for you to pick up this particular?
Thank you, Vikas, for asking this question. Like when we saw all the problem statement, the water scarcity is the closest one which was to our hearts. And initially, we were just 2-3 members. We were thinking about it, especially from the biotechnical background, which I mentioned about the members. Then we thought that it is just not the biotechnology people. We require other stream people also. And then we gathered a team comprising of almost all streams like mechanical engineer, civil engineer, and biotechnology. And we also took an electronics and computer savvy in our team so that we can come to a logical solution with advanced technology incorporated. And since in our institute, we are also working on hydrogen projects. So in hydrogen, when we are making hydrogen, green hydrogen, from recycling materials like biomass, this biomass can be used for grey water treatment or other kind of water treatments. So we thought that we will use this as a trailblazing method if it is possible, and we started working on it. and after few days of research and work, we could come down to a very reasonable, very cheap, and sustainable solution for the grey water management.
Yeah, that sounds great because treatment of grey water or having clean water, no one can understand better in during these times better than the people living in Delhi, because we have a huge pending problem of the river Yamuna being so filthy, and so the manner in which we've seen it in visuals everywhere. So we can really understand the enormity of the situation and the need for the something which can cleanse the entire water ecosystem. So we would now really like to understand the solution that you've come up with. So can you please share that with us?
Yeah, so to start with, like the basic technology incorporates, first of all, we did extensive research on the gaps available in the existing technology. What are the gaps available, like the areas which are not covered efficiently by the technology? Like we see everywhere, every household, reverse osmosis water purification plants are being used at small scale, even at the industrial scale. So this is a mechanism which consumes a lot of electricity. Then we thought that we should have a osmotic procedure wherein the water flows with gravity, and so that we can reduce the electricity consumption. Secondly, the biochar, which is a new technology, like we don't have to rely upon the old coal fossil fuels for purification of water. The biochar, we developed a unique biochar from soya beans waste material or soya chunk. So this biochar was capable of absorbing almost all the impurities of the water, and it in a shorter time frame. So this biochar was again treated and made to an extent that within seconds it can remove almost all purities from the grey water. In addition to that, we made the water run over an extended surface wherein it came in contact with TiO2 and UV light radiation. The UV light radiation is not required to be given artificially. It can also be done using sunlight, direct sunlight. Or we can use solar panels where there is no it is not possible to give direct sunlight. With the UV light combination and TiO2, the bacteria and all infectious materials get killed. Then thereafter it goes through a filtering process, and at the end we get pure water. So it's a continuous process and continuous production of water from grey water to treated well. Even the water sample which we created was in drinking limits, though we don't claim it to for the people to drink it, but it had removed all the heavy metals and impurities from the water. So this is a unique technique. Not nobody has used it even in the world, because we have done extensive research on this. So that's how we could come with a solution. And biochar is very, very cheap to produce. Many factories or industries are producing it. Even we are thinking of starting our own startup in this area. Let's see what happens. So we could treat water like about 1 lakh liter of water. It just requires about 400 rupees for treatment. So it is very cheap. It can be used in urban areas, semi-urban areas, industrial areas, even in rural areas.
So yeah, you mentioned some bit of economics behind this. So tell us how quickly and easily can this be deployed at various locations, and in terms of cost also, as you just indicated, how will it be so cost effective for the institutions who are making use of this particular innovation of yours?
Yeah, because like what we have done, we have developed our own prototype, which we showed and displayed in the hackathon as well. Like it costed us about 20,000 rupees, which will last for 5 years, and it can treat water and clear water for domestic purposes for 5 years. So for 20,000 rupees for 5 years, overall maintenance cost doesn't move more than 2,000 extra.
How much of water can this particular thing treat in, say, for in a day or so? So let's try to kind of quantify this.
Yes. Because we like what we have done is like we had taken a family of 6 people, and water requirement we have taken about 500 liters. So 3000 liters per day it can easily do it, and a safety margin was kept. So about 3000 to 5000 liters of water it can treat per day, and the machine can it is a static machine which can be installed in the houses and directly incorporated in the system. So it is like 5 years, 22,000 is no cost at all actually if you see, and we can scale it and make an industrial model as well. And for a larger scale, we are still working on it. Though it will work on the same principles, but few modifications are required to do for the large scale up model.
So I believe your this one scale model which you just mentioned, that was highly appreciated, and of course it went on to win the competition for you. So now coming to this larger scale model which can be used for industrial establishments. So till what point have you succeeded in moving towards that direction? Have you started working on it? Are you there at and covered some distance? At what point are you in that particular case?
Already done the exact the entire development of the model. We have done on simulation this thing so that we can treat water up to 5 lakh liters a day, and it is in final stages. So the costing is as of now is coming for to good about 25 lakh rupees, and the model can work for 25 years, and we are still trying to reduce it further so that it is cost effective, easy to handle, dismantleable, replaceable, and recyclable. So all the sustainability factor and environment factor, friendly factors are incorporated in this model, and we are quite sure that our solution will help people in improving their lives, especially in treatment of grey water.
Right. So taking this conversation a little further, like, what are the plans that you have for the future? Like as you mentioned right now, that you are working on a commercialized, model which can treat bigger quantities and serve bigger areas. So do you have a roadmap prepared, and what is the future plan? Like, where do you want to take this from here?
So, Vikasji, like what we are thinking that we will first file for the patent of our model, and we are working on the large scale production as well, like how we can go ahead and trying firstly the research work which is still going on, like large scale, and it is still in final stages. Further improvement on the quality of the biochar, how we can incorporate that. All research work is going on, and it is in final stage. Maybe another 2 months we should be able to file for our patent, and then see like if we can go for a large scale production in like if we get some help from the government or from any private player who's ready to invest with us, then we are definitely will take this to a larger scale. That's what the plan is as of now.
That's wonderful, Rishikesh, and I congratulate you and your team for coming up with this
Thank you,
novel
sir.
solution. And we wish you all the best. And we would really like to see you guys in the market with a tangible product which is
Thank
serving a larger amount of areas and larger amount of people and benefiting the country as a whole. So, very good
Yes.
job. Congratulations once again. And
Thank you,
our
sir.
best
Thank you
wishes
so
are
much.
with you, Rishikesh. So, nice
Sure.
talking to you and knowing about what you've done. And
Thank you, Vikasji, for giving this opportunity on a very nationwide, larger platform, and hopefully things will go in the right direction.
They will.
Quite
A
hopeful.
lot of eyes are on you, and we are looking forward to your innovation coming
Yes.
into the market and serving people. Thank you so much for joining
Yes.
us today, Rishikesh.
Thank you, Simon. Thank you.
Greywater management presents an opportunity to conserve water and reduce environmental impacts. When properly treated and reused, greywater can significantly lessen the demand for freshwater resources, reduce pressure on sewage systems, and contribute to sustainability. Innovators like Tech Chargers are making a positive impact in this area. We will meet another team of SIH winners in the next edition. Keep watching.